So we're going to continue talking about counting subsets of a set, i.e. we're talking about combinations. So there are two things I want us to note before we look at our next example. The phrase at least n means n or more. At least it's like a lower bound. And the phrase at most n means n or fewer. So it's essentially like an upper bound. All right, so now that we have those phrases, let's look at an example. Suppose we're looking back at that example where we had a group of 12 people. Suppose the group of 12 consists of 5 men and 7 women. So part A, we want to know how many five-person teams can be chosen that consist of 3 men and 2 women. So you can think about this as like a two-step process. So step 1, you're going to choose the men. And step 2, you're going to choose the women on the team. So let's start with step 1. How many men in total? There were 5 men, and I need to select 3 of them to be on this team. So it would be 5, choose 3. Now, the women, there were 7 women, and I need to select 2 of them to be on this team, so it'll be 7, choose 2. And then from here, you can use the product rule. Because these two steps, they're independent. They have no overlap. They have nothing in common. Selecting the men and selecting the women, those are separate things. So you're going to take and multiply 5, choose 3, and 7, choose 2. So this will be 5 factorial for 3 factorial times 2 factorial. 7 factorial over 2 factorial times 5 factorial. The 5 factorials will cancel. So then we have 7 factorial on the top. So then 2 factorial. So the 3 factorials will cancel. 2 factorial is 2, and 2 factorial is 2, so these will cancel with this 4. So we're getting 7 times 30, or 210. So there are 210 different possible five-person teams that have 3 men and 2 women on them. So now let's look at part B of this question. How many five-person teams contain at least 1 man? So remember, when we say at least, that means one man or more. So you have two options in how you do this problem. You can use the addition rule or the difference rule. The easier one in this scenario will be the difference rule, so that's the one I'm going to start with. All right, so the difference rule here, the number of teams with at least one man, it's the number of total possible teams minus the number of teams that do not contain any men. So you take the total possible numbers of teams. So if there were no requirements on this team, there's 12 people and I need to choose 5 of them. And then we need to count the number of teams that don't contain any men. So the team would be entirely made up of women. So there are 7 women and we need to choose 5 of them. So 12, choose 5. I think we did this before. It's 792. 7, choose 5. It's 7 factorial over 5 factorial times 2 factorial. This will be okay, the 5 factorials cancel. The 2, use this with a 3, so then it's 792 minus 21, or 771. Now, the other option you could have done here is you could use the addition rule. So the number of teams with at least one man, you add up the number of teams with one man plus the number of teams with 2 men plus the number of teams with 3 men plus the number of teams with 4 men, and finally plus the number of teams with 5 men. And you add these all up because these are all independent events. They don't have any overlap in them. So on the first one, if I'm selecting 1 man, it's 5, choose 1. And then out of the 7 women, I need to choose 4 of them to complete the team. 5, choose 2. And then there's 7 women, I need to choose 3 of them. The number of teams with 3 men, it would be 5, choose 3. And then out of the 7 women, I need to choose 2 more. If I have 4 men, it would be 5, choose 4. And then choose 1 woman, so 7, choose 1. Or finally, choose all the 5 men, and then you're not going to choose any women. And if you multiply this all out and simplify it, you'll get the same answer you got before, 771. So it's up to you. Either method will get you the same answer, but in this case, for this specific problem, using the difference rule is a little bit easier than using the addition rule. So the last one we're going to look at, how many 5-person teams contain at most 1 man. So here I would suggest to use the addition rule. Because what does at most one man mean? It means it either has no men or exactly one man. So the number of teams with at most one man, number of teams without any men, plus the number of teams with one man. So this would be, if you have no men, it'll be 5, choose 0, and then 7, choose 5. Here, I'm choosing one man, so out of the 5 men, I'm going to choose one of them. And then out of the 7 women, I'm going to choose 4 of those. So this first one would be 21. The second one would be 175. So if you add them together, you should get a total of 196. So there are 196 of these 5-person teams that contain at most one man.